you to just see if you could come up with the antiderivative just by thinking about it. Were most of you successful? What do you think it is? What do we think? Take the derivative. What's the derivative of sine? Cosine, but then you have a chain rule, so you'd have to multiply by 3. But the 1/3 counteracts that and cancels it, so that makes sense. Plus c. Was this pretty difficult to do as of right now? Yes, and you can imagine this is an easy chain rule where it's just multiplying by number. If the chain rule were much more complicated, it could really hurt our brains. So we're going to learn today what's called integration by substitution. And what that is a way to handle some chain rule problems. It will not work for everything, but it will help us deal with some product, quotient, and chain rule problems. This is the only upper integration technique that you learn in Calculus 1, in Calculus AB. So this is essentially our last day on integration techniques. As you saw, there are infinitely many different integration rules. So this is not the end all with integration. In fact, that's where Cal 2 picks up, is more integration rules. The beauty in Cal 1 or Calculus AB is that if you can't do it with U-substitution, then it's probably not one of your problems. So you can kind of bank on the fact that it's either a U-substitution problem, an algebra problem like yesterday where we simplify, or it's not a problem. Calculus BC students don't have quite that same ability to just rely on one method. They have to think a little harder, but so in Cal 1, you have to use the substitution method. Anytime, time out before I start, try algebra first. If algebra simplifies it, don't try substitution. Does everyone know what I mean by that? How many of you do quotient rules for derivatives that you should not do all the time because you don't use algebra? Yes? Quit. Use algebra. Algebra will simplify a lot. So, step 1, try algebra. If that fails us, and we have two functions multiplied together, two functions divided, or a function inside a function, like cosine of 3x minus 2, then we are going to use substitution. Again, don't forget to try algebra first. So step 1, you're going to let u be the inside function or the more complicated function. I am going to show you a way to kind of help you pick out the u. For now, think about the most complicated part and try that first. Sometimes you will pick the wrong u first and it won't work. And you'll try again. Solve for dx, or sorry, find the derivative of u with respect to x. Find du dx. Solve for dx, and then do a substitution or a change of variables in your problem. Essentially, you're going to change the x's to u's. If you did everything correctly, all of the x's will disappear, and you will be left with an integral only in terms of u. As you can imagine, this won't work for everything. It will work for everything in Cal 1. Everything that you would be given to do by hand, it will work. As you can imagine, we could come up with problems that this wouldn't help us on. But we'll talk about that at a later date. Do the integral, change the u back to x, put a plus c. So we're going to revisit the bell ringer, but now with a technique after you've had time to write. So the first type of chain rule, or the first type of U-substitution occurs when we need a chain rule. And what we're going to do is let u be the inside of the function, the inside piece. The piece that's causing the problem. So I'm going to let u equal 3x minus 2. I'm going to find du dx. This is probably the last time I will write this quite this way. I'll shortcut it a little bit, and I'll show you that on the next problem. But for this problem, we'll cross our T's and dot our I's and do everything exactly textbook. Would you agree this derivative is 3? The derivative of u with respect to x is 3? I'm going to solve for dx. If I'm going to change my variables to u, I need to change my dx to something else as well. Would you agree with that? So, I'm going to cross multiply, or however you get dx by itself. But I get du equals 3dx. So 1/3 du equals dx. So far, so good. Now I'm going to pull a switcheroo. Remember I said 3x minus 2 was what? U. And dx is what? 1/3 du. I'm going to do the antiderivative. This is just a constant, right? So it just hangs out in front. What is the antiderivative of cosine? Sine of u plus c. But I didn't really want u's. I was just using u's to help my brain. What was u?
Oh, wait, 3x minus 2.
And so I get 1/3 sine of 3x minus 2 plus c. And I know you're thinking, Miss King, that was a lot easier just thinking it through. You can imagine they won't always be ones you can just think through. So this gives us a step-by-step approach to handle something with a more complicated inside or a product or something that we can work with. So this is the first U-substitution problem. Any questions? So that's what we're going to do. U-substitution. All three of these are kind of like the bell ringer problem. They are a chain rule. The derivative of the inside is just a constant. You could probably do these in your head if you thought about it real hard. We're going to work these with a chain or with a U-substitution. What would u be? Good. U equals 3x plus 17. What would du be? This is how I always write this. It's because I'm lazy. I don't know. Du equals 3dx. If you want to write du dx and solve, that's great too. You know, math people, we're lazy. We take shortcuts. That's what we do. So I get 1/3 du equals dx. Any questions so far? Now I'm going to do my substitution. So I get the integral of the square root of u times 1/3 du. Questions? So I replace the 3x minus 17 with u, and I replace the dx with the 1/3 du. This step is optional, depends on where you're at in your integration process. I'm going to go ahead and rewrite that integral. If you feel like you can do it without a rewrite, that's great. What would I do to rewrite the square root of u? Okay. And so now I will take, I don't know if I'm sticking on steps 1 through 4 or 5 through 8. I don't care on your homework if you stick on the, I think it's labeled the same way. No, I'm not going to look to see what's in which box. Add 1 to the power. Divide by the new power. When we divide by a fraction, it's the same as multiplying by the reciprocal. So I get 2/9. What was u?
3x plus
To the 3/2 plus c. Check it. 3/2 times 2/9. That gives you 1/3, right? 3x plus 7 to the 1/2. And then chain rule, what would you multiply by? U prime, which would be 3. And so the 3 and the 1/3 would cancel, leaving me with just 3x plus 7 to the 1/2 power. Oh, 17, sorry. My bad. Okay, any questions about that?
So we left the square root alone because we're just messing with the inside function.
We want to pick the part that's making it complicated. Square roots we can do. Square roots with things other than x inside are problematic. I'm going to skip this one, if y'all are okay with that. Why am I skipping it?
It's
Just like the bell ringer, except with a 7 instead of a 3. 1/7 sine of 7x plus 5 is the answer. Okay, we'll skip to e. What would be a good choice for you? Good, negative 4x plus 7. What would du be? Negative 4 dx. Again, if you want to write du over dx equals negative 4 and then cross multiply, you can. So I get negative 1/4 du equals dx. Any questions so far? Do the switcheroo. E to the u times dx, and what was dx? I'm going to rewrite that. Unnecessary step there. Most of you can handle the 1/4 being over there instead of in the front. Whatever you want to do. Sounds great. What is the antiderivative of e to the u? And then don't forget the last step, because is this truly the antiderivative of the original? No, my original didn't even have a u in it. Remember, I picked the u. I put the u in there. I need to clean up my mess, fix it, get rid of the u. Negative 1/4 e to the negative 4x plus 7. Okay, so all three of those were chain rule problems. Chain rule problems are pretty easy to pick the U out because you pick the inside part of the function. The next slide is going to have some that aren't quite as obvious on what you should pick as U. And I'm going to show you some tricks to choose U wisely. X squared plus 2 to the 5th power times x. Why is that a problem? Why can I not just integrate it? Product rule, chain rule, lots of problems. I could multiply that out to the 5th power. If it were a square, that's what I would do. I would actually do the algebra and then just integrate using our rules. But at this point, I have to kind of make a decision, is raising something to the 5th power worth my time? And if I have another option, that answer is probably no, if I have another option, because a 5th power would take me a while. So I would like to find another option, and I need to choose a U. And I'm going to do my best. I'm going to pick the part that looks more complicated. So what looks more complicated, the x or the x squared plus 2? X squared plus 2. Now, I'm going to teach you a little way to do this in your head, because most of you at that point are like, well, why didn't you pick x squared plus 2 to the 5th power, right? And maybe I should have. I don't know. We're going to try something and see what happens. This is the first one. You will get to where you can see them in your head as you go. I'm going to find du. What is du? 2x. 2x dx. Everyone listen to this. There are people who are math majors who don't know this, and it could save them so much time if they knew this. If your du variable shows up again in another part of the function, you made a good choice for your U-substitution. Write that at the side of your notes. If your du shows up in another part of the function, you have made a good choice for your U. And I'll show you why as we keep working. So a lot of people do this just as trial and error, trial and error, trial and error. Well, trial and error take you a while sometimes if you choose wrong. So if your du shows up, you've made a good choice, and I'll show you why. So get dx by itself, and I get 1 over 2x du equals dx. Pull the switcheroo. So I have the integral of x times u to the 5th times 1 over 2x du. And I'll stall there for a minute. But you see how I've replaced the x squared plus 2 with the u, and then the dx with the 1 over 2x dx. Well, why is that showing up a big deal? Well, watch what happens. Cancel. And I saw that coming because I saw that it appeared again, and when I divide by it, they're going to cancel. So we're going to see how you can kind of pick that out before doing all the work and going, oh man, nothing canceled. I have to try again. So a lot of people will have to pick it and try again and try again and try again. You can kind of stop at this step and see if you've made a good choice. And this step could be done in your head. Do you agree with that? You could do a derivative in your head. So that's good news. Rewrite 1/2 the integral of u to the 5th du, which is 1/2 times 1/5 u to the, no, u 1/6, thank you. 1/6 u to the 6 plus c, which is 1/12. U was x squared plus 2. to the 6th power plus c.
You don't need du in that anymore.
No, when you do the antiderivative, those always go away. We are very new at this. There's lots of room for error. What should you do at this step? Check it. Check the derivative really quick. 6 times the 12th is 1/2. X squared plus 2 to the 5th power times 2x. What happens to the 2 and the 1/2? Cancel, give you 1, so I end up with x times x squared plus 2 to the 5th power. I did a good job. Now, I will tell you this next problem. Honestly, the easiest way to work is probably algebra. Multiply it out, do a power rule, done. We're practicing U-substitution, so we're going to do a U-substitution. And if I had a power on one of these, you'd want to do a U-substitution. I don't know. I would make the argument you'd probably rather do algebra, but again, we're learning, so we'll learn. Why do I need something? Why can't I just take derivatives as it sits? It's a multiplication problem. It's product rule, right? So I have a problem, can't do a product rule. So I'm going to pick the more complicated looking piece. That's our go-to, which is x squared plus 3x minus 5.
Would you want to distribute that amount in, or like, would it matter at the end?
No, since it's just a constant, I probably wouldn't because it makes your numbers bigger, but sure, either way would work fine. If I let u be x squared plus 3x minus 5, what is du? 2x plus 3. Have I made a good choice? How do you know? There it is, right? Now, I'm going to go ahead and solve and get dx by itself, but some of you could even make the substitution where you replace 2x plus 3 dx with du. You see what I mean? Some of you high-level substitutioners could handle that. I'm not going to do that because it's quite a bit to think about in your brain. As you get really good at this, that may be something you do, where you leave it like that and just substitute du in for it. You see how that piece, you could replace this whole piece with du. That's what I did. But anyway, so I'm going to do 1 divided by 2x plus 3 du equals dx, which gives me the integral. I'm going to move the 9 in front. That is not at all necessary, but if you got options. U times 2x plus 3 times 1 over 2x plus 3 du. So that u is this part. This part I haven't done anything with yet, so it still exists. And then the dx is 1 over 2x plus 3 du. So I replace dx with 1 over 2x plus 3. Now again, if you took that shortcut, it kind of cancels the 2x plus 3's before you put it down on paper. But so the 2x plus 3's cancel. Again, that means I made a good choice. When that happens, 9 integral of u du. Will you occasionally make the wrong choice the first time? Yes. So pick a different u. Try again. U squared over 2. So 9 over 2 u squared. And what was u? Check it. See if it works. So you tell me on the next one. Would you agree that on the next one I have no algebra that can help me? So the last one I could have done with algebra. We didn't need a U-substitution. On this one, is there any algebra that can help me? I cannot break up a square root, right? So that square root, it's on the bottom and it's staying there. So I am forced to use a U-substitution. Now the beauty is, you know, a U-substitution will work, or they wouldn't put it on Cal 1 homework. So that's the beauty of, you only have one choice of options. Again, when you get into Cal 2, it does get a little more complex because you have other options, but for now, we don't. So, what would be your choice for U? Why x squared plus 1? It's more complicated. It hasn't, when I do the derivative is going to have an x, a 2x. Remember, constants, we could care less about constants one way or the other. And that x on top, hopefully, will cancel with it.
Probably just the U was that.
Oh, sorry, you're right. It is. I should quit talking and writing at the same time. You are very right. U equals x squared plus 1. And du would then be? Good question. Do I want the square root or the negative 1/2 power in with my U choice? Why not?
That's outer function.
It is outer function.
Outer, the negative 1.
When I do the derivative of that, that's going to be really nasty, isn't it? Is that showing up anywhere else? The derivative with the power and nasty. So, is that okay that that was your first thought, though? Yes. It didn't work. We tried. So you see what I mean by sometimes you'll pick the wrong U? We tried it, but the derivative was so nasty it didn't show back up. So I'm going to try again with something that the derivative might show up. 2x dx. And so 1 over 2x du equals dx. So, pulling my switcheroo, I have the integral of x over the square root of u times dx, which is 1 over 2x du. So here's the moment of truth after you've picked a u and you think it works. The moment of truth is, do all your x's cancel? If they don't, you cannot integrate with more than one variable. You cannot take an antiderivative with, you don't even take derivatives with more than one variable very often. We sure don't want to do antiderivatives with more than one variable. So if those x's don't cancel, you've chosen incorrectly. Do they cancel? Yes. And so I'm going to rewrite that integral to be 1/2 integral. What would I rewrite the square root of u on the bottom to be? U to the negative 1/2. So remember, constants, they're not going to bother me. I'm just going to move them out of the way. U to the negative 1/2. Anti-differentiate. So I will raise the power by 1. 1/2 sitting in front. I would get 1/2. And then divide by the new power. Dividing by a fraction is multiplying by 2. Am I going too fast on that antiderivative? Okay. 1/2 and 2 cancel. So I'm left with u to the 1/2 or the square root of u. What is u? X squared plus 1. Would you get all the points if you wrote x squared plus 1 to the 1/2 power? Yes, it's the same thing. Doesn't make any difference. It went away here. check it. In fact, I think we don't want an x on top. Probably, right? Can you take the derivative of this? 1/2 x squared plus 1 to the negative 1/2. You see how this throws that to the bottom when you do that when you do the derivative? And then times 2x. That would get rid of the 1/2 in front, and then that would be where your x on top came from. How many of you could have done this one in your head? Probably not. So you see we kind of made a transition from, there were a few at the beginning you could have done without a U-substitution, just by really thinking hard. But we've also picked up things we couldn't do before, that now we can do. That this is too much for my brain to handle all at once. Too many things going on. But with a U-substitution, it's not too terrible. All right, let's look at the next one. Pick a U. I would say no. Why does it not matter?
I mean, if I take this derivative.
Good, the derivative of sine is cosine. The derivative of cosine is negative sine. Tomato, tomato. You can pick either one. If you don't like negatives, then pick sine. If you don't care, then pick cosine. And remind me why I even need a U. Why do I need a U? Yeah, why? Why can't I just integrate as it sits? Product. So I'm going to keep reminding you, because on tonight's homework, maybe I throw one in that doesn't need a U-substitution. I don't know, right? So don't forget that we could just use plain old rules. We could just multiply it out. But I can't multiply out sine times cosine. It is what it is, and you have to work with it the way it sits. du is cosine of x dx. So 1 over cosine of x du is dx. So I can rewrite my integral to be the integral of cosine of x times u times 1 over cosine of x du. And you could probably, some of you are probably looking at this going, I can see how you could have done some of that in your head, you know, maybe as far as the canceling out the cosines and stuff. But for now, we're going to show everything. So I get the integral of u du. Questions so far? The antiderivative of u du is 1/2 u squared. And remember, don't leave it that way. At this power is 1. So raise the power by 1, divide by the new power. 1/2 sine of x squared plus c. If you had worked this the other way, the answer would not look identical. If you had chosen cosine instead of sine, it would be a correct trig identity equivalent answer. So it wouldn't look exactly the same, and that's okay. Because of trig identities, occasionally may not be as cut and dry. All right, the next one. Now, the last one, we decided we could have picked either one. Do you think either one's an option on this one? What's a better choice on this one? The first one. Why? It's more complicated. And when you take the derivative, what's going to happen to the 4? It's going to go away, so my derivative is only going to involve sine. Do I want the cube involved? No. Why not?
Because you can put that.
Then it's too nasty, right? It'd be, the derivative would be, it wouldn't involve only a sine and a constant. It would be too much. So making those choices wisely. What's the derivative of cosine? Negative sign. So negative negative makes a positive 2 sine of theta. D theta. So 1 over 2 sine theta du is d theta. So my integral is u cubed times sine of theta. Does everyone see I'm just replacing things at this point? Anyone confused at this step? What's happening?
No, so like whatever you don't touch in the beginning to make the u stuff, you just leave it in there.
Right. And you hope that it cancels. If it doesn't, you've done something wrong. You've just chosen a u incorrectly. Sometimes you will just have to trial and error it. Sometimes the u's are harder to choose than others. The better you get at it, the easier it gets to choose them, but the 2 did not cancel, and so a lot of times we look for everything to cancel. Remember, constants, we're fine. Constants we can move out of the way. They're not a problem. So I get u to the 4th divided by 4. Which is 1/8. Don't forget to replace your u. And u was 4 minus 2 cosine theta. Don't forget on your homework, check your answer. I am not checking every answer, but you need to. Try the next one. Again, on your homework, I could care less what step you're on and when you're on it, as long as you have the right answer. This is due on a Tuesday. We don't have school Monday, so it's 2 days. I do. I do pretend that. But you don't. Martin Luther King. What'd you choose? ln of x. Everyone agree? 2, yes, no, maybe. It doesn't matter whether you choose 2 or not. If it were me, I'd probably move the 2/3 out of the way anyway. But you don't have to do that. That's not important. Okay. I do like natural log of x being my u. If you have a 2 in front of it, it will not mess you up. It will just be throughout it's just a constant, so it'll just be in your u instead of out. It doesn't make any difference. Why is natural log of x a good choice? Because the derivative of natural log of x is 1 over x. Does 1 over x show back up? You see the 1 over x there? It's not written as 1 over x, but it's there. So it's a good choice. X du equals dx. So I have the integral of 2u over 3x times dx. And what was dx? X du. And what happens to those x's? They cancel. And so I get 2/3 integral of u du. I don't care how you did it, you all ended up with 2/3 integral of u du, right? Even if you put the 2 in the, it doesn't matter. It did make this stuff a little yuckier, which is fine. 2/3 times 1/2 u squared.
I keep forgetting I have to check the
Antiderivative. Yeah, don't forget the antiderivative. 1/3 u was natural log of the absolute value of x plus we're going to not get to the last two. We'll do those tomorrow. This very last one is quite complicated, and we'll talk about why it's quite complicated and how we can still do it even though it's quite complicated. Because it is a little messier. By the way, here's your homework. It is that worksheet, page 342, 18 through 26 even, and 27. It says Monday. We don't have school Monday, so thus Tuesday. So all of that is due on Tuesday. Tomorrow we have 2 problems to finish and some grading to do, and then other than that, tomorrow will be a day to work and ask questions. So, and we have the rest of yesterday's to grade and talk about, and then the 2 yucky problems at the end. Any questions? How do we feel about U-Substitution?